James is an engineer, is experienced with aluminium fabrication. So I wanted him to be part of it so that, the work the complementary skill will help us to achieve where we are going to. And Theophilus here is a researcher. Right. He's working hard on, his focus is on fish, on anything fish in agriculture. So he's a agric researcher. He's also working on his PhD. Apart from that, he has also published other works that is very interesting. So we decided to work together and see what we can bring solution, how we can bring solution to our community, especially in the area of food processing and food preservation. That's the key. Food preservation is the key. I'm passionate about food preservation, and I want it's my desire to see. I believe that more than food production, managing food will give food security that we are desiring. United Nations goal, So that is why I'm very passionate about food preservation. So we have talked about processing fish and how to use solar to make it possible in fish processing, so dehydrating it so that it will have longer shelf life. So, and that is why we are proposing this design. So we expect that your skill in fabrication, you help us to bring ideas together. Now, this is just a prototype, a sample prototype. I believe in design. With my design experience, it has been my philosophy that in designing, I don't want to assume that the materials I have is available to, especially when it is a distant design. I don't want to assume that what I have is available to the people I am talking to or where I'm communicating my design to. So I want to have collaboration of ideas so that we know what to substitute and what to keep. So this is a tentative design. What we will discuss will decide changes that will happen on this design, and then a final one that we will begin to use for fabrication immediately. Yes, and then also for costing, because I discussed with you the need for us to cost it and know what we are doing and have proper plan to work with and run with. Yes. So, Mr. Theophilus, are you with us?
Yeah, I'm with you.
Okay, so yeah. So this is we are considering dimension of the net to carry the fish to be, I'm talking in millimeters, to be 1,000 by 500 millimeters. That's 1 meter by half, right?
Okay.
Want to start with that first. 1,000 by 500. How do you see that? It's going to carry all the fish.
But if you want, I could snap you existing samples of the regular smoking cane. I could snap you how they are nets.
Well, it may not be that. The only thing that will be relevant is if you are giving us maybe a dimension of the size of what they do. That one will be relevant. But the picture may not be that relevant, you see, because but what I'm saying is that, for example, the sizes of fishes we have, do you understand? The sizes of fishes will determine per time what will be dried. You are telling me, you said the last time we talked that you wouldn't want the fish to be sliced, isn't it?
We could also slice it. Most people slice fish. It's only the smaller ones that they wrap around. But for the larger ones, they cut them in size. Sometimes in cuts of 6, sometimes in cuts of 4.
Okay. So now, what do you recommend, or what do you think we should work with? Should we, because we want to have a consistent thing to work with, so that we can predict and we can say this is what this can do. Should we go with the one that is cut or small one that is wrapped?
We should go with the one that is cut.
Okay, the one that is cut.
Because that one gets done faster.
Yeah. Okay, that's fine. So we go with the ones that are cut. Then and we are working for a test, right? For a test, we can,
Yes.
from whatever we get from this test, because this test will determine a lot of things, a lot of changes will come. So for the test, we are going to work with the standard size of 1000 by 500 size. So it's going to the fish will be spread over that net. Okay. So, and this, to explain a bit, explain principle of how this work. Unlike the other type, I think you are familiar. There are two types like this. Now, let me see if I can quickly show you another design. There's there's this design. Can you see it?
Okay, yeah.
Now, they are not the same. They don't operate the same way. This design operates like it uses hot air in its performance. So you can decide to make it like a cabinet. It's a cabinet dryer. You make it 4 nets or maybe 4 or 3, depending on how you design it, right? But the other one, which we have been, okay, this one works with it's infrared. That means we are not taking advantage of heating the air. We are heating it direct from infrared rays. What I mean, infrared rays from the sun. Now this is a glass. We're also going to add a mirror here. There will be a mirror, as I discussed with you, James. There will be a mirror. The mirror is to reflect back extra heat to amplify it. So we'll put a mirror here, and the mirror will be reflecting heat into this. And here it will trap the heat. If it goes through this glass, it will trap by what we call greenhouse effect. It will trap it inside here. And when it traps it, there is a black, as you can see, through the glass, there is a black surface, a black aluminum surface that will be absorbing the heat, right? So when it absorbs the heat, it transfers it to the food. Let me explain the principle of how this works. If you have ever been under a roof that does not have ceiling and there is a heavy sunshine, how do you feel?
Very hot.
It's very hot. That's it. That's the principle. What happens there is that when the sun hits the roof, the aluminum roof or anything or zinc, whatever it is that was there when you entered, when it hits, the thing goes directly to surface. It's even though there is air flowing, sometimes you will still feel that heat. It will come directly to your surface. That's how the sun actually heats up. If the sun is hitting the air, you will discover that the sun is very far away, but its energy, you get it on your body. Even though there's wind, it's not stopping that energy from getting to your body. So it hits by sending the rays direct to the surface. So despite the air. So that's the principle we are applying here. The sun is sending the heat direct to the fish, no matter the whatever interference, right? Are we together?
Yeah, I'm with you.
Yeah. So I consider this also very interesting because it's a bit faster to go that way as well, rather than waiting for air to be heated up or the space to be heated up before we get a result. We just go straight and it helps us to get faster performance. That is what I've considered. So we're going to test it, but we will test this if we have time. If we have time, we can test the other one. You can compare with the two dehydrators and see which one gives best performance, if that makes sense. Yeah, okay. We are using two methods of heating the whatever is inside it. So that's how it works. So when it heats up, then with this, if you observe here that this place is lifted, there is a gap here. So this is where air blows through to carry the moisture away from the fish. So as the fish is being heated, just like what happens in the smoking, the heat is coming from under, right? And the top is open. So the air just blowing off the moisture from the up while the heat is coming from under. But this type, we reverse it. The air is coming from under, but the heat is coming from the top. Are you getting it? So and that's what makes the technology unique. So that's the basic principle. So we
I wanted to
agree.
confirm.
Yeah.
Are we trying out both method, or we are choosing just one?
Well, we are choosing this one, right? Yes. Well, I was offering that if you want, we could try both method, both dehydrator method. You understand? But
Yeah,
the other method, right?
the
The
Huh?
other method is presently in the dehydrating industry, or rather in the over there in Nigeria, as a matter of fact, those who are dehydrating are using the other method, that's heating the air. That's what is already being used. If you go to any fish farmer now that is drying its own fish,
Okay.
you will see that they have their oven, what they call the dryer, right?
Yeah.
He uses that same method. They heat up the same, but we are talking about sustainability, how we can maximize energy.
But in terms of cost, which is more affordable?
This will be more in cost. This will be more affordable. This will be more efficient than the other one, right?
Okay.
This is more affordable. This is more efficient. You have less. You won't lose energy more. And another advantage of this one is that when we have gotten the solution we are looking for, and we now decide, okay, we want to replace the way we are trapping heat. We want to make it more effective, right? In the sense of whether there is sun. I mean, not whether there is sun. Of course, we always need sun, but maybe consistency of the heat of the sun, right?
Yeah.
We decide and say, oh, we want to use the other way of trapping energy, which is photovoltaic cell. If we want to use that one, it is easy for us to incorporate it here than the other one.
Yeah.
So that's why this one is preferable.
Yes, sir. I've been looking at the project proposal so far. I've been trying to find out loopholes, or rather disadvantages, that this processing method may have as compared to the existing alternatives. And so far, what I can see is that in raining seasons like this, do we have any hope of this machine running?
That is what I just told you now. In rainy seasons, you can replace. Are you getting it? Now, this one we are using now, we can replace it with the one that is on the roof over there everywhere, as in people are using to power their house. In rainy season, as long as there's light, it's not depending on heat, it's depending on light. Okay. Photovoltaic cell depends on light. So as long as there's light, even if it is not much, it will still trap heat. It will still trap energy, and that energy will be converted to heat. So if you are using it here, you discover that even if there is rain, as long as there's light, it will still trap. And the energy, if it is, as long as it's infrared powered, the energy it will be using will not be much to achieve. Are you getting it? It won't drag. For example, if it is not infrared and you are using something like heat element to drag it, you just bring down the whole solar. It will not work. I mean, it will drag so much energy. That's what I mean. But if it is infrared, which is very easy and it's heat direct, it will take little energy and give you best results. So you discover that at any time apart from night, except even if you have battery, you will see it work at night. If you have battery, you understand? Element find it hard to use battery. It will drag all the battery away. But if it is infrared, it will use battery and still be heating your food and giving you the results.
Yeah. So we can because it runs like an hybrid.
What do you mean?
I mean that the provisions you made, should there be no sunlight during rainy seasons, but so far there is light. we can incorporate that technology into this one, and this one run as an hybrid, right?
Exactly. So, if we get the result in this, what's it called, temporary state, so to say, are you getting it? If we get our results here, then we know that if we are bringing photovoltaic cell, we will still get the same. We don't have problem. Are you getting it? Do you understand?
Yeah.
So, because we are in the testing level, we don't want to bring in photovoltaic now.
Yes.
Do you understand? So, but when we get our results, then photovoltaic can replace this one for us for any time, for you to still get your results. So we will now, rather, we will use infrared, real infrared design for the top, so that if you have solar in your farm, if you charge your battery in the night, you can still dry. You can dry in the night. You can as well dry in rainy season, as long as there is light. It will get power. And if your battery is charged, you will dry. But if it is the other way around of the way we have been doing, you can't use battery. Forget it. You understand? Except you have another way. There are many other ways anyway we have not explored over there, which is there's something like a sand battery. So you can store heat and reuse it in the night. But that's another talk of another day. So that is where we are now. Are you okay with that?
Yeah, that's very wonderful, sir.
Okay.
That's very wonderful. I look forward to seeing it work, because those were my considerations. I was just thinking earlier, I was like, what of when we have rain all through? Like this season over here, we are experiencing a huge amount of rainfall. So that's why I brought that up.
Yeah.
Then also I wanted to ask, I don't know if you remember when I came to your factory here in Nigeria, when I met you at one of your warehouse where you were working, when we were building that machine. I saw something I was trying to, you were constructing something that could cook beans under sun.
Yeah.
I don't know if that's the same technology you are applying here.
Yes, the same technology works here.
Okay.
You see?
I remember you were explaining to me then about how the aluminum would trap the heat, and then you were timing it to see how long. You tested it for eggs. We both tested the eggs that was cooked that day, but you said you were going to try for beans.
Yeah.
Okay. Now I get it clear.
Yeah,
Thank you very much.
See how this one works. This one is also hybrid of drying and cooking. Now see how it works. As you can see, it is suspended. As it's suspended like this, it is drying. If I want it to cook, all I need is to bring it down. There is a control here which James will handle that one during construction. There's a control to bring it down, so there won't be space here. As long as there's no space here, it has turned to oven. Are you getting it? So, now, during the testing, we are going to apply all this in. We're going to see how, because your fish may need, because of the way market wants it, especially the local market. The local market always want the fish that is almost done. You understand, that they can even eat dry like that. So if we are offering such product, what we do is that we both cook it at the same time, dry it.
Right. Yeah.
Yeah. So in the workings of in testing it, what we do is that at a time, maybe initially at the start of the process, we close it up and it cooks. For some hours, we are sure slow cooking is wonderful. You need to try it. Slow cooking is wonderful for meat processing. It brings in any spices that you put on it. Any spices that you put on it comes out well. It enters it well. Slow cooking is very wonderful. So you will see the power of slow cooking when we are done with it. So you cook it first, then you dry it, and that'll be very useful.
Okay. That's very good. That works fine with me, sir.
Yeah. So over to James will further dimensions and the rest. I'll discuss with James. James, are we together? I understand that we will need to conclude here and we'll do further
Yes, we are, sir.
material sourcing with James, and yeah, it gives me updates on materials, material costs and everything. We'll put down the bill of materials and cost it, and we will start in earnest constructing it, and right, so that we'll start seeing our results come through. Thank you so much, gentlemen, and we'll meet again for further discussion probably next week.